The point of contact is the common point of a circle and its tangent. That is, the tangent touches the circle at the point of contact. Let us consider a hoop, which is placed on the ground with a stick as its tangent. Now, in this figure, if a line OA is drawn from the center O of the hoop to the point of contact A, it appears to be at a right angle to the stick. The theorem states that a tangent to a circle is always perpendicular to the line joining the center of the circle with the point of contact. We know that there can be one and only one tangent at a given point on a circle. Also, the line segment joining the point of contact of the tangent to the center of the circle is known as the normal to the circle. Tap the button to understand this better with an example.
Let's work with a line across a circle to understand how a secant or a tangent can be created in different configurations.
Fill in the blanks with the correct values. drag and drop the labels next to the correct options. Fill in the blanks with the correct values. Fill in the blanks with the correct values. Let's summarize what we have learnt in this topic. We know that there are three possible ways a point and a circle can be placed. The point can lie inside the circle, it can lie on the circle, or it can lie outside the circle. Let us perform an activity to know more about the number of tangents from a point inside a circle. Let's draw a circle and mark a point A in the interior of the circle. Now try to draw a tangent or tangents through this point. We see that all the lines passing through this point intersect the circle at 2 points. These lines are secants of the circle. Therefore, we can conclude that no tangent can be drawn to a circle from a point inside the circle. Let's consider the case of a point on a circle and mark that point as A. We try to draw tangents to the circle through this point. Here, we see that only one tangent to the circle can be drawn through this point. Let's consider the case of a point A in the exterior of the circle. We draw tangents through this point. It is observed that exactly 2 tangents can be drawn from this point. In this figure, AB and AC are 2 tangents drawn to the circle from the exterior point A. Here, B and C are the points of contact of tangents AB and AC respectively. Thus, exactly 2 tangents can be drawn from a point external to the circle. When a tangent is drawn from a point to a circle, the length of the line segment from that point to the point of contact is called the length of the tangent to the circle. In this figure, AB and AC are the lengths of the 2 tangents drawn from the point A. When tangents to a circle are drawn from an external point, their lengths are always equal. Let's consider A to be a point external to a circle. We draw two tangents from A to the circle as AB and AC. Then, according to the theorem, AB is equal to AC. Now, let's join the center O to A, B, and C. It is observed from the figure that angle BAO is equal to angle CAO. So, OA is the angle bisector of angle BAC. Thus, the center of a circle lies on the angle bisector of the angle between the two tangents drawn from an external point. Tap the buttons to understand this better with more examples. When tangents to a circle are drawn from an external point, their lengths are always equal. Fill in the blanks with the correct values. 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 Let's summarize what we have learnt in this topic. A circle is a closed curve which consists of all the points on a plane at an equal distance from a fixed point. The fixed point is known as the center of the circle, and the fixed distance of all points from the center is known as the radius of the circle. Many objects of daily use, such as wheels, coins, and computer disks, etc., have the shape of a circle.